What's up, class? It's Mr. Wicklehouse, and today is probability day 2. How exciting. This is going to be great. We're going to start this video off talking about exclusive and inclusive. So mutually exclusive events are two events that cannot happen at the same time. So, as far as the probability goes, if the events can't happen at the same time, the probability of A or B is equal to the probability of A, which we know how to find, added to the probability of B. So you just find the probability of each and then add them together, and that will be your probability for the mutually exclusive. The other one, mutually inclusive, is two events that can happen at the same time. So, the probabilities look like they're written the same way, except we've got this little piece right here. So, probability of A plus the probability of B minus the probability of A and B. And remember that this is just the probability of A times the probability of B. Okay. All right. So let's look at an example. Say you draw a card from a standard deck. What is the probability that it is a diamond or an ace? This is inclusive. This is a mutually inclusive probability because, why? Why is this inclusive? Well, because I could draw a card and it could be a diamond, but it could also be an ace. So because it could be a diamond and an ace at the same time, then it's inclusive. I could draw a card and it's the ace of diamonds. So my probability is going to be written that way. So my probability that it's a diamond plus the probability that's an ace minus the probability that it's a diamond and an ace. Okay, so the probability of it's a diamond is 13 over 52. We've talked about that before. There's 13 cards, or 13 diamonds in a deck, and there's 52 cards in the deck, so the probability of drawing a diamond is 13 out of 52. Okay. The probability that it's an ace. Well, there's 4 aces in the deck, and 52 cards in the deck, so the probability that the card is an ace is 4 out of 52. We have to subtract the probability that it's a diamond and an ace, because one of these aces is a diamond and it's already been counted here, so I have to subtract one of them off. So then when I go through and do my addition, plugging every piece in, 13 over 52 plus 4 over 52 minus 1 out of 52 is 16 out of 52, or 4 out of 13. Okay. All right. It's not so bad. Let's look at another example. Couple others, actually. So, we've got a dog that has a litter of puppies. And the dog has 1 black female, 3 brown males, 2 brown females, and 1 white male. Well, the first probability is that it's brown or a male. Well, it is inclusive because there's 3 brown males, so it could be brown and a male at the same time. There's also 2 brown females, so not necessarily, but because it could be both, it's inclusive. Okay. So probability that it's brown. Well, there's 1, 4, 6, 7 dogs. There's 3 and 2 brown ones, so that's 5. So the probability that it's brown is 5 out of 7. Probability that it's a male. 7 dogs still. There's 3 brown males and 1 white male. So that means there's 3, 1, that's 4 out of 7. Probability that it's brown and a male. Well, that's just going to be 3 out of 7. So I add and subtract, and I get 6 out of 7. Okay. So now let's look at the probability that it's black or white. Well, there's not any black and white dogs. They're either black or white. So that's going to be exclusive, because they can't be black and white at the same time. So the probability of black or white is just the probability of the black plus the probability of white. There's 1 black female, 1 white male. 1 out of 7 plus 1 out of 7 equals 2 sevens. Pretty simple. Alright. Moving right along. Here is conditional probability. So it's written as the probability of A given B. That's what this little line means in probability given. And it's equal to the probability of event A happening given that event B has already happened. Okay. These problems, you'll be given a table and you'll be able to find these solutions given the table. So let's look. Here's our table about superheroes, superpowers, males and females. You can see the total for each column and each row. Okay. So we're going to find the probabilities of these couple examples. So the probability of a male given that they fly. Okay. That means we need the male who flies out of the total who fly. So we can see here from our table that 26 males fly. And the total who fly are 38. So the probability of that is just 26 out of 38. I don't care about any of the rest of this stuff. I'm just looking at things that fly because that's what I've been given. That's what I know. That all of this probability is only concerned about people who fly. Okay. Now here's one probability that they fly given that they're male. So I know that they're male. So I'm only concerned with this column right here because that's what I know. I know they're male. And what's the probability that if I pick one of them, they're going to fly? Well, there's 26 who fly out of a total of 48 males. So that's the group that I'm looking at. So it's 26 out of 48, or in other words, 13 out of 24. So you're just trying to identify what the given is, or what you know, and looking at that for the total. And then you're taking the other piece of whatever that it is that you're looking at. Okay? Alright, here's another last example, and then this video will be over. So on April 10th, 1912, the Titanic set sail from Southampton, England, on its maiden voyage. We all know what happened to the Titanic, blah, 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 blah. They went, here's a bunch of information, 400 miles from New York, 1140, struck an iceberg, and sank. After the disaster, the British Parliament launched a formal investigation and issued a report along with recommendations for future ships. The report is commonly referred to as Lord Mercy's report. Data in the two-way table are consistent with the data in the report. So they wrote down who survived, who perished, and totals, you know, just like kind of like the last table. So we're looking at some probabilities, and the light went out on me. Hold on. Here we go. And these are conditional probabilities because it's conditional because given that the person perished, given that the person was a woman, so the probability of a man given that they perished. You see? So we know they perished. We want to know the probability that they were men. So I come up here to my table, my handy dandy table, and find the total that perished, and that's the 15 over 13. Now I'm going to put the number of men over top of that. So 1352 out of 1513. Okay. Now this one is the person survived given that the person was a woman. So this is the probability survived given that it was a woman. So looking at the total for women is 425, and how many women survived? 316. So the probability that the person survived given that it was a woman, 316 out of 425. Okay, here's another little bit of information for you. To determine if events are independent events, okay, then we look and see if the probability of A is equal to the probability of A given B. What I mean by that is, so we want to see if people surviving and being a woman are independent events. So we look at the probability to survive. Well, there's 711 people survived out of 2,224. So there's the probability that they survived. It's about 0.32 or 32%. Probability that they survive given that they're a woman? Well, we already did that. Right? And that's about 0.74 or 74%. Is 0.32 and 0.74 equal? They're not. So these are not independent events. So no, not independent. Okay? So that's how you would do that kind of question. And that's the end of day 2 of probability. Have tons of fun.